All right. We got, sorry, let's see this. We've got all of this from chapter 1, okay? We're going into chapter 2. This is the key to chapter 2, symbols. So the first thing we got to learn is some symbols, okay? So let's go over some basic symbols we're going to be learning. And then we're going to learn how to put those symbols in what this is called is a conditional statement. We're going to learn what a conditional statement is. Okay? Alright, so first symbol. Wow, what's that? Triangle? Yeah. Now, you can also, it's meant for change, right? The change of something, but, you know, or it's triangle. So in geometry, we use it for triangle, right? In algebra, you'll see it like this, or calculus. The change of y over the change of x is equal to the slope. You might remember that from last year if you had me. Okay? If you did it, then you might not remember it. But this is calculus. Okay? So sometimes it can be used for the change of. Okay? But most of the time it's just a triangle. Especially in here. Okay? So symbols have multiple meanings just like words. Okay? We know equals, right? And plus and minus, divide, times, right? So we won't go over those. But congruent, that's a huge one in here. That's huge. Congruent, that means the same. It doesn't mean equals. Although it's pretty much the same thing. What? It's congruent to equals, but it's not really equals. Okay, so in geometry we use congruent unless we're talking about a measure. I think you guys realized last semester or last chapter you've seen this a lot. The measure of the angle, right? Or the measure of the angle LMN, right? So this can be set equal. The angle LMN can be set as congruent to something. Okay? Congruent and equal. They're two different things. Okay? Alright, so let's make that symbol a little better. It's an equal sign with a little I forget what we call that on top. Alright. Here's a really cool this symbol can be used for a couple of things. Okay? It's a big dot. Sometimes we use it for times, right? Okay? But in our symbols, we're going to be using it a lot for and. This big V is or. This arrow is then. 3 bars, supposed to mean if and only if. Right? That's why there's 3 bars. If and only if. But in here, I reduced it to just if. Okay? Alright, so some other things we might need. Parallel. Perpendicular. Okay? Intersect. If you had me last year, intersect. Okay? Not. Okay? Not. This is huge. It's just the squiggly line, that the same one that's above the equals. It's just this squiggly line. It also means similar. Later on in the year, when we start doing similar proportions, right? When we start talking about proportions, it will also mean similar. So it's weird because it means not, which is nothing like similar, right? Not, and then it also means similar. So, and then I was like, are we sure it's not just a backwards one? And we're like, no, it's the same one. It's the same symbol means both. Okay, so symbolic logic is a little different than math. Okay, so these are symbols that we use in symbolic logic. There's some other symbols. Okay, so you could use. This is very popular. Whereas, such that, it's a crazy life. No, I'm just kidding. Means therefore. Okay. Okay. All right. So let's talk about some conditional statements. What is a conditional statement? First of all, a conditional statement. It's what we call an if-then statement. Okay? It's called an if-then statement. Okay? All it means is you have an if and then you have a then. Right? If line 1 is parallel to line 2, then line 1 does not intersect line 2. Okay? If they're in a plane, we're talking about a two-dimensional system here. Okay? Your geometry is going to be two-dimensional geometry. We're not talking about three-dimension geometry. Okay? Three-dimensional geometry is something called non-Euclidean geometry. So, non-Euclidean is 3D, or what we call spherical geometry. Okay? What you will be learning is called Euclidean. Okay? Two-dimensional. Okay? Let me give you a small example of what that means. Like we said, if two lines never touch, they'll be parallel, right? Okay, if two lines are parallel, then they never touch. They never intersect, right? except in three-dimensional space. Hence, these lines will never touch, right? This is what's called skewed. Okay? This is what's called skewed. This is in 3 dimensions. Okay? 3-dimensional geometry is a lot harder and a little bit more intense than 2-dimensional, but it's still pretty cool. Okay? 2-dimensional, parallel. Okay? You can still be parallel in 3 dimensions, right? It's just, you can also be skewed. None of these touch. You feel me? Oh, yep, never touched. Alright? So, I'm not a big English guy. I can write papers if I have to. But I don't like to write so much in math. So we take this and we create if-then statements out of it. Watch how easy this is. If line 1 and line is parallel to line 2. So if they're parallel, right? Symbol for parallel. Then they do not intersect. Not intersect. Bam. We just wrote that whole sentence. 5 symbols. Right? Okay. This is what's called the condi, the conditional statement. Okay? I call it the condi. Okay? Conditional. Right? Condi. Right? And then there's the conv. Okay? Okay, if I use just conv. Called the converse. Okay? The converse is really, 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 really easy. Okay? And I'm going to change something really quick. Because I use this in green, right? I'm going to write this in green. If parallel, then not intersect.
Are we supposed to write that in green too? Because I wrote mine.
It's okay. I mean, whatever works for you. But I just figured because I wrote this, it would make more sense if I just kept the colors coordinated. Does that make sense? So sorry about that. So conv just means this. Okay? We're just going to flip these two. That's it. We're just going to flip those two. So this goes here. If they do not intersect, then they're parallel. Okay? Now this is very, 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 very important. Is this true? Is this true? Is it true that 2 parallel lines don't intersect? Right? That is true, right? Okay? So that's true. Is this true? If they don't intersect, then they're parallel.
Yes.
Right? Okay? So that's true. Test. Okay? When they are both true, This is what they call when they are both true. When the con D and the con B are both true. It's called a biconditional statement. Okay? It is a biconditional statement. Okay? Alright. You would think that's it, but that's not it. Alright, there's two more. Inverse. So I call it the envy. Uh-oh. Oh man, they're making it hard on me. What? I still have it. All day. And they made it, try to make it hard on me. What? I got this. All day. Alright, so, I'm not even wearing my Jordans today.
Hey, you want to put a pair on?
Yeah, I obviously don't need them. I just killed that basket. In B, okay, or what we call inverse. Okay? The inverse is this, but not. So you're taking this and you're going, it's not this and it's not this. Okay, so it's the first conditional statement, right? But it's saying not the conditional. So what this is not the con D. Okay? So you take the con D, right? And you go, if not parallel, then not, what's two nots make? A positive, right? Two negatives make a positive. I don't say, I'm not going to the store. That would be silly, right? I'll be saying, I'm going to the store. Right?
Yeah.
Okay. So, two nots make a positive. So then, not is just, yeah, it is intersecting. So, if they are not parallel, then they intersect. Is that true?
No.
Yeah.
Yeah.
In two-dimensional space. In Euclidean geometry. Right? True. Okay? And then, we have the last one. You want it in red or purple?
Purple.
Alright? The last one is called the contra. Or the contra positive. The contrapositive is taking this and doing that. It does to the inverse what the con B does to the conditional. It just switches it around. It just switches around the inverse. Okay? In essence, it's an inverted, it's the opposite inverse of the con B. So it's a not envy of the con D. Weird, huh? But that's really what it is. It's the negative inverse of the conditional statement. In other words, I just take this and I switch it around. If it intersects, then it's not parallel. Okay? That's what we're doing this chapter. Okay? So those are the notes for chapter 2, and now we got to start doing chapter 2, right?